She went to her kitchen window and she was looking out the window, saw the leaves start, going past the window, started seeing branches, so on and so forth. Tornado came, ripped that kitchen wall down, ripped her out of the kitchen. She landed face first in her driveway, and she was visibly shaking. And this is 12 hours after the event, and had to go to the hospital. Got stitches in her lip right here. I think it was like 15 or so. But what I haven't, or what we saw there was, once again, curiosity can get the best of you. But if you take shelter, you put yourself in the best situation. That's great. And she had a bathroom in the middle of her house. All the walls were still standing about 15 feet away from her kitchen. So I tell everybody, take shelter if there's a tornado. So, all right, going back to what I do. I do a little bit everything here at UK. Research, forecasting, modeling for farmers, producers across the state. When is there periods of livestock heat stress, cold stress, winter, spring conditions, great outside, drying conditions, so on and so forth. Disease prediction, fire blight is a big issue here in Kentucky when it comes to orchards and whatnot. Extension, you guys go to the Farm Machinery Show, you'll see me there. You'll see me out and about across the state giving different presentations. Teaching, if you come out of this class today and say, man, I really like weather and whatnot, you can take a biometeorology class this spring. So we meet Mondays and Wednesdays between 11 and 12. We have a Tuesday lab between 2 and 4. Good news is you guys have Thursdays and Fridays off. So that's always a plus. Lastly, or I should say second to last, event forecasting. I get to go to every home football game. Now, it's fun for the most part. But if there's storms in the area, it doesn't get so great for the meteorologist. 50,000 plus people. I have not had to evacuate yet. I hope I never have to. But if there's lightning within 6 miles of the stadium, everybody has to get up and go take shelter. So, like I said, definitely don't want to do that, but it can happen. And lastly, as Carmen was saying earlier, if there's a lot of snowfall this winter, I do talk to the president along with other people around UK, and could have classes canceled. So you guys love that, but I'm up for about 6 hours during the overnight making sure this snow is going to verify, because president's already canceled and so on and so forth. So weather's fun, but sometimes you get put in pressure-packed situations, and it's not so fun. So, all right, definition of weather and elements. All right, state of the atmosphere at some place in time. We already went over climate, so I'm going to skip that stuff. But described with all these variables, elements, temperature, humidity, cloudiness, precip, wind speed, wind direction. All right, I'm done. I'm taking vacation. What's the weather like outside today, guys? Overcast, that's weather. Humid. Overcast, Oakland, is that right? Owen. Sorry, I thought I heard Oakland earlier. So, well, that's your new nickname. So, all right, anything else? What's the temperature like outside, guys?
It's like 70.
70s, all right. What's the winds like?
Calm.
Do what?
It's calm.
Calm, okay, all right. Is it muggy? Yeah, I heard it's humid out there. Okay.
No vortexes.
No vortexes? Any Sharknadoes today? If only.
No hurricanes.
No hurricanes? How about, let's see. Well, you guys about hit everything up here, so you guys are meteorologists already. So, all right, so meteorology, study the atmosphere and the processes that cause that weather. So, why is it in the 70s right now? Why is it cloudy? Why is there no hurricanes here right now or Sharknadoes? So we got to answer all those questions. So here's some of those elements, what a meteorologist is going to tell you guys. You'll see all this on the 6 p.m. newscast with Mr. Bill Meck or Chris Bailey most of the time. Maximum temperature, minimum temperature, the dew point, how much moisture is in the air right now. If you guys had to guess, what's our dew point like right now? Is it high or pretty low?
High.
It's pretty high. It's pretty muggy outside. Relative humidity, did you guys see any dew on the grass this morning?
Yes.
Okay, so pretty high humidity right now. Precipitation amounts, we measure rainfall to the hundredth of an inch. Whenever it comes to snow, I tell everybody, I talk a little bit about this later. It's a little harder. A lot goes into snow accumulations. General rule of thumb around here, 10 inches of snow equals 1 inch of liquid equivalent precipitation. So now this can change. I will tell you guys, we got like 17 inches of snow back in 2015. So this ratio of 10 to 1 was more like 17, 18 to 1. So a lot of snowfall during a short period of time. Air pressure, is it falling? Is it rising outside? That's going to tell us if high pressure or low pressure is on the way. That'll be helpful whenever you guys learn how to forecast wind speed and wind direction. Where is the wind blowing from? I want that to be key. Whenever we talk about wind direction in meteorology, forecasting, if I say northerly wind, I'm saying the winds are coming down from the north. If I say southerly wind, winds are coming from the south, from the Gulf of Mexico. All right. Sky cover. I heard some, yeah, I said overcast today. I was impressed with that. So, yeah, overcast skies, 100% coverage. And now I wanted to go over these two right here. Difference between a watch and a warning, all right? There is a lot of confusion on this. A watch, issued when hazardous weather is possible outside, all right? Tornado watch, severe thunderstorm watch, so on and so forth. It's possible. It's not a guarantee it's going to happen. It's not a guarantee a tornado is going to hit your house or your location, but it's possible that day. So what is the watch telling us? Turn on your weather radios, watch TV, watch social media, be in tune today because it could happen.
So when they issue a watch, what's the percent possibility, probability that it goes wrong? I mean, like, is it like 50%, 20%?
Yeah. This is all issued by what you call the Storm Prediction Center. They're out in Norman, Oklahoma, and they have various percentages associated with those areas. I'll go through some of that Storm Prediction Center a little later, but yeah, there are associated percentages. They're not necessarily high, and whenever we talk percentages, it's your percentage chance within 25 miles of any given point.
So does it change based on like the severity of something? So if it's a tornado, does it get one thing versus, like hail? Or...
Sometimes there's a better chance of, based on the pattern that's set up, sometimes there's a better chance of a tornado. Maybe you have more wind shear in the atmosphere. That's winds increasing with speed and direction, turning in direction with height. Sometimes there might be a better chance of what we call squall line, damaging wind event through the area. Other times, like you saw in 2015, it was a combination, or 2014, sorry, baseball-sized hail and tornadoes. So it varies. This is the weather, so always changes. But going back to this, NWS weather warning, it is here. Take cover. You're in that warning area. You hear that beep, beep, beep on the radio. Pull over to the side of the road, go in someplace, take shelter, because if it's a tornado, you're in that area that could be harmed. Severe thunderstorm warning. I've driven through 70-mile-per-hour winds. It's not fun. So maybe if you're in NASCAR or something, but not me. So. All right, once again, you got all those elements we were talking about a second ago. I wanted to show this graphic right here, all right? If you took our atmosphere and just took a section of it, going from the ground up to space, this is what it would look like. It's divided into different sections all the way up 375 miles to the top of our atmosphere. You get into that exosphere, you're out of Earth, I guess. But we come down here to something called the troposphere, all right? This is the zone of weather. This is where all of our rain, what we're most concerned with here on the surface. And you can see our troposphere up to what we call the tropopause before you get into the stratosphere. It only extends up, it fluctuates. It's going to be lower at the poles, it's going to be higher at the equator just because it's warmer and whatnot. But around this area, about 11 miles up. So our zone of weather compared to the entirety of our atmosphere is actually very minimal. So, all right guys, first weather element. You guys tell me, we're going to look at some records across the world, across the U.S., across Kentucky. All right, let's start up here. What do you think the coldest temperature ever recorded for an inhabited location is?
What is the period of time?
Our total record, which goes, about 150 years or so.
Fahrenheit or Celsius?
Yeah, we're not going back to the Ice Age or something, so
Let's stick to Fahrenheit.
Fahrenheit?
Fahrenheit.
-22.
We gotta go up or down from there, sorry. We're going farther into the negatives.
-50.
Negative.
75.
Okay, I heard -50, -150, so we gotta split that.
-75.
All right, we got pretty close. Okay guys, I'm horrible at pronouncing names, so if any of you guys can get this word, that's great. Siberian village of Omyakon, I don't know, we're gonna go with that. Very small village, 4,000 people, 1933, got down to -90. I don't know about you guys, but it got down to the negatives back in 2015. It wasn't fun around here. So, and that was just like -15, -20. I can't imagine -90. So, all right, uninhabited. Uninhabited, how did we get a temperature on this? Well, we got weather sensors across the globe, so nobody lives here. What do you think?
Negative 100.
-200.
We're going the right direction. -200's pushing it a little bit. But you guys did say -100 a little bit ago.
Oh.
Now, -90's cold. I don't know what you call -127. But Antarctica, right, nobody lives there. And for obvious reasons. So no one wants to witness that. Back in 1960. How about here in the U.S.?
-50.
Yeah.
You know, that's actually pretty close. All right, Montana, 1954, Rogers Pass, almost -70 degrees Fahrenheit. Ouch. There's frostbite waiting to happen. How about Kentucky?
Negative 25.
Down.
-36.
42.
Did you know that?
No.
We got close. Got close, -37. Look, right down the road from us. Shelbyville, Kentucky, 1994. -37.
What's your weather?
Now, I will tell you guys,
You gotta find one for me.
Weather MD.
What?
Atmosphere.
Atmosphere Ashley, pretty close today. All right, so I wanted to tell you guys real quick, -37, I'm a weather geek. Back in 2015, we did have all the snow in March, but we had another big snow in February that year. Following that snow, skies cleared. We had a really good snowpack on the ground, and temperatures just plummeted, all right? I was watching a station down in Richmond, Kentucky. It was a mesonet station. And some of these places are in low-lying locations, but if you get a large snowpack and sky is clear, temperature's gonna start dropping. I think they got almost 2 feet of snow down in Richmond. So we got quite a bit, but yeah, they got a lot more. But you could just see that mesonet station just constantly dropping through the night.
So So you just basically have, no way to absorb radiation.
It's re-radiating. Yep. Long wave radiation back through the atmosphere. And so we saw that thermometer over there, or temperature sensor. It kept dropping through the night, and it got down to minus 32 in Richmond, Kentucky. So I thought it was almost unbelievable. We were getting close to that all-time record low here in Kentucky. Yeah, did you?
So that wasn't like an average of what went on there, it was just from one specific station.
That was just one station. Yeah.
One point in time.
Yeah.
How long was that sustained?
So we were out of school we canceled UK during this time. I talked to the president and everyone in that group and whatnot. And I went to Purdue for my undergrad. And just to give you a comparison, I had a math recitation at 7:30 in the morning, calculus and whatnot. And we had another cold air event, and temperatures dropped. I think it was like minus 15 or so up there in West Lafayette. But if you've ever been to West Lafayette, the winds blow a lot harder up there than what they do here. Our wind chill got to, I think it was minus 40 or whatnot. And of course, I'm wearing 3 layers of clothes, walking to recitation at 7:30 in the morning. I don't even think that was enough. But if I recall right, Purdue's threshold for a canceling class was like a wind chill of minus 45. It's like, well, what's the difference between minus 40 and minus 45? But anyways, you come down to Kentucky, all right, up in West Lafayette, Michigan, and Minneapolis, so on and so forth, they're used to this cold weather. Here in Kentucky, we're not necessarily used to those Arctic air events coming through here. And students aren't always prepared, all right? Winter coats up in Minnesota are one thing, and you're used to that cold weather. Down here in Kentucky is another thing. So we did have all the snow. I remember that week we canceled school for, I think, the first 3 days of the week because of snow and no one could get around. But then this cold air came in the next Thursday and Friday. We canceled school the entire week because we didn't want students walking around. When temperatures here in Lexington were like minus 15, minus 20, but add the wind chill, it was approaching minus 30 in this area. So different area of the United States here in Kentucky.
How long would it take for you to get frostbite?
It depends on your situation. I got some slides I'll talk about on wind chill here in a second. It can take us all the way down to 5 minutes if you're not wearing the proper protective clothing, so on and so forth. So, yeah. All right, warmest in the world. Let's go the other direction. The coldest uninhabited is 127, inhabited is minus 90. What do you think the warmest in the world was?
143.
143. Well, not too far off. 134 degrees. I'll tell you guys what. You guys think it was hot in Kentucky this summer? You think it's hot today?
It's a little up.
Yeah, 134 in Death Valley, California is nothing to mess around with. So, 1913, guess what? We're the warmest in the world. We're the warmest here in the United States. All right, how about Kentucky?
112, 118.
112, 118, right there in the ballpark. Greensburg, Kentucky. This is down by Campbellsville. 1930, 114. So I want to tell you guys, 1930, this was one of our worst droughts in Kentucky. I talked about 2012 earlier. If you look at graphics, I don't think I have it in this presentation today. 1930 was 3 times worse than 2012. So, but whenever you have drought, normally you have heat with it. So as you saw in 2012, we got the triple digits. Well, drought 1930, guess what? 114. All right, measuring air temperature out there. You guys, I'm not going to go over this. You guys have all seen a thermometer in your life. Cricket chirps. I found this few years ago, and I thought it was interesting. You guys can test this out later on tonight. Temperatures must be above 54 degrees, check mark today. Count the number of chirps in 8 seconds, add 4 to it, and that's supposed to be your degrees in Celsius.
This is no farmer's sale?
So you guys test that out tonight and see how close you are. Methods for accurate measurements. So some of you may be going out and doing research. You want to make sure you have some protection on those sensors. This is an example of one of the boxes we have out on our north farm at Spindletop. And this is a white box. What does white do? It reflects solar radiation. So we don't want that solar radiation directly hitting the sensor, or it could alter our measurements. Once again, have some ventilation in that box, but it's protected from that direct sunlight. This is the same thing you would see on a weather station. This is a more complex weather station. This is what we call the CRN station, part of the Climate Reference Network out at Woodford County Farm. And you can see these, I'll say, white shields. These are solar radiation shields. And sometimes you have fans within these that keep dust and whatnot from building up on those sensors. This is a picture of one of those temperature sensors you would see in one of these boxes here. Not a whole lot to it, depending on the weather station you get. Some are plug and play, some are a little bit more in depth. And then I wanted to show you guys this. If you don't need a constant record of weather data out in the field, you can get something called a weather meter. Sometimes athletic events, you like to have these, just for example, over at football games. You don't want to launch fireworks up in the air if you have wind speeds of more than 15, 20 miles per hour, because you don't want those things coming back at your face. So you can measure wind speeds, you can measure temperature, humidity, whatever it may be associated with what you're doing using those weather meters. So I wanted to show you guys this. I did come across this problem. If you're ever working with weather stations, nature does come in and impact you sometimes. So I had a nice nest inside my box out there at North Farm recently. Had some, I guess they were yellow jackets or whatnot. So those are always fun to mess with until you get stung in the face. So temperature variations across Kentucky, across the United States, something to watch. Time and day of the year, obviously we're losing sunlight now. Warmest time of the year, we got to look at the tilt of the earth during the summer months, and we're losing daylight now until we get to December and goes the other direction. Cloud cover, I want you guys to look at cloud cover almost like a blanket across the sky. All right, during the day, you have cloud cover. What does that do to temperatures? Well, so during the day, we're blocking solar radiation coming in. So we're typically going to stay cooler during the day. But during the night, a blanket effect. It's trapping all that heat, all that long wave that's trying to go to the surface, go back up through the atmosphere. It's not letting it out. Keeps it warm during the night. What happens when there's clear skies during the day? It gets warmer outside. During the night, clear skies, all that radiation re-radiating back out through the atmosphere. It gets cooler, very quick-like. You guys actually saw that today. We had fog outside. I know it seemed cloudy outside, overcast skies, I heard that. But you guys should see that cloud cover lift. We did have some fog. Fog favors clear skies, very light winds, and some moisture. Where did that moisture come from? Did you guys get wet last night? You get poured on? So, yeah. And when the ground is not snow covered, it's warmer. So like I said, back in 2015, we had all that snow cover, 2 feet of snow in some places. All that radiation's getting reflected back through the atmosphere, getting very cold outside, minus 32 in Richmond.
And so it's warmer when the ground is dry just because the water's not there to absorb the heat.
Yeah, yeah. So, heat index. Oh, she just... So, heat index is really what it feels like outside, all right? We talk about temperature, we combine that with humidity, all right? There's a dry heat, and there's Kentucky heat, all right? We're feeling that Kentucky heat right now, and we've felt it for a few months, it seems like constantly. It's been very hot and humid outside. I got your heat index info right here. So, you take a combination of that air temperature and humidity, you look at this chart, just to be vague terms, very hot, extremely hot, what it feels like to the human body. You can see these different shades of colors. You just take an example. It's 110 degrees with 70% humidity. You're in this purple area. Heat index is very high, and you get in this category. Heat, sunstroke, highly likely with continued exposure. Step that down. We were here in the 90s